Now let's look at Prolog variables. So in the previous section, we were discussing uh, the facts on its own, and none of them, these are atoms. This is an atom, this is an atom, and this makes a compound term, which is actually a fact right now. Now let's assume that instead of using actual atoms, we move towards what you call variables. Now again, I've got four facts written here, none of them which have a variable in it. As mentioned before, for something to be a variable in Prolog, the syntax states that either it starts with an underscore or it starts with a capital letter, or it could be all capital letters. Now, this fact written here, it states that France is a city in the country Paris. So this particular fact has two parameters in it. It has two arities in it, Paris and France. So in fact, not only Paris and France, all of the facts, city and country, this predicate city and country requires two parameters. This one, first one is possibly the mentioning of the city, and the second one mentions the country. And how do I read this? Paris is a city in the country France. Similarly, and as you can see here, as with all facts, they all are finishing at with the full stop. Similarly, Berlin is a city in the country Germany. Cairo is a city in country Egypt, and Munich is a city in country Germany again. So these are four facts that are mentioned in my knowledge base. Now I can write a query. As mentioned before, we can write queries with actual atom values, and it will simply return true or false based on its perception of the existing knowledge base. But let's just say that I use a variable in my query like we're doing right now. As you can see here, Berlin is Berlin as mentioned before, but this country is a variable. Now, how do I know that? Is because the capital is starting with a capital letter. Now, basically this query is different because now it won't be resulting in the a true or false term. It was true or false here when my query did not have any variables in it. It was a simple true or false term. But now since my query has a variable in it, it will require instantiation and backtracking to determine what country is Berlin belonging to. Now, instantiation and backtracking we'll be looking into in a bit, but essentially what's happening here is that my Prolog will search my knowledge base for all facts that have Berlin in the first parameter. If it finds a match in it, it will instantiate the second part, say, for example, Germany, with this variable. And my answer will actually say that country that you're looking for is Germany. So basically, if you look at it, I'm in a way I'm asking, what country is Berlin a city of? So basically, if I read this, that's what it sounds like. What country is Berlin a city of? So the response should not be true, false. In fact, it should tell me the country that you're looking for based on my knowledge base is Germany. And how did it reach that conclusion? Well, it started off with city and country facts with Berlin in the first parameter, in which case there's only one fact that satisfies that particular condition. And when it finds that fact, it instantiates the second value with the variable here, and it reached the conclusion, yes, the country that you're looking for is Germany. To find out which cities are in Germany, on the other hand, now as you can notice here, my city parameter starts with a capital letter, in which case now I'm trying to find out what cities, according to my knowledge base, and there are more cities in Germany, but according to this knowledge base and these four facts, there are only two facts that satisfy the city and country predicate with Germany as the second parameter. And that is, the first one is Berlin and the second one is Munich, in that particular order. Now, what's interesting here is this, Like all other programming languages, Prolog is also a sequential language. And what that means is that when my Prolog knowledge base is searching through facts, it starts at the very top and goes down from there. So according to this sequence, my city, the first instant where the fact with Germany as a second parameter is true is when city is Berlin. And the second fact where the fact where Germany is true for the second parameter is when city is Munich. And that's why when I run this code in a query, it returns two values. See, city and country. What city is a city in the country of Germany? And it starts searching from the top. City and country, Germany. Now, since this does not meet my requirement, the second parameter has to be Germany. This fact is ignored. It looks at the second fact. Now, this fact satisfies my second parameter, Germany. So, okay, I got a match. So I have a fact in which the second parameter, Germany, matches. That means this must be Berlin. So that's why associates the value city with Berlin first. But it doesn't stop there. Prolog requires that it goes through all of the knowledge base, just in case there are other facts that may match the same criteria. And by chance, we do have such a fact. In which case you can see here, when Prolog progresses to the last fact, it finds another fact, which the second parameter is also Germany. And in this case, this time it instantiates the variable city with Munich now. So that's why it found two matches that satisfy the second parameter as Germany, city and country fact. And the first time it does it is when city is Berlin. And the second time when it does it, its city is Munich. Now, on the other hand, the first example we discussed in where the country parameter is my variable. So basically what we're saying, Berlin is a city in what country? So basically my Prolog will start searching from the top, look at the fact that states Berlin is a city in the country. So basically the first parameter has to be Berlin. So this fact does not meet that requirement. This one does, in which case, if Berlin matches the first parameter, then the second parameter and for which country exists must be Germany. And that's why it instantiates the variable country with the value Germany. So when I'm saying instantiation, it means that basically I'm allocating a real value, an actual value to a particular variable over here. Okay, now let's look at this problem here in which I am not only dealing with one, I've got facts that not only have say one parameter, but they have three. Okay, let's see what's happening here. Okay, this first fact says that aubergine is a vegetable. So I have two atoms, vegetable and aubergine, and basically this is the predicate, this is the quality, and this is the noun that I'm talking about. So aubergine is a vegetable. Okay, that's my first fact. Potato is a vegetable and tomato is a vegetable. Similarly, we got three more facts over here. Chicken is a type of meat, beef is a type of meat, lamb is a type of meat. So I got these 6 facts over here. Now let's look at this fact here that takes in three parameters. And how is it read? Tangine is a dish that requires the ingredient aubergine with the quantity 250, whatever it is, grams or whatever it is. So basically what it's read is that this is my dish over here. This is some dish that requires this, what you call it, item at with this quantity. So this is how it's read. Same thing goes with this one. Tangine requires the ingredient of tomato with this quantity. Beef, sorry, stew is an ingredient, is dish that requires beef with this quantity, and stew is a dish that requires ingredient potato with this quantity, so on and so forth. Now, What is the concept of anonymous variables? Now, anonymous variable means that I can choose to run a query by not necessarily accessing all variables. So if I, for example, want to run this query, I can run it by just entering 2 parameters, even though this fact requires 3 parameters. But if I choose, I can write this a query for ingredients just by 2 variables. Now, let's look at what's happening here. The first example, as you can see here, the switch interface that basically changes colors when I'm using variables as opposed to atoms. So even though we are very well aware that a capital letter means it's a variable, but the switch tool changes the color to just make that difference more prominent. Anyway, so tangent, now as you can see here, ingredient amount are both variables. So as mentioned before, when we're working with variables, my Prolog simply takes this fact, that query that I just posted. Now what have I posted here? Let's try to assess, let's try to understand the plain English version of this query here. Tangine is a dish that requires what ingredient to what amount? So I'm not sure. So what happens is that my Prolog, my knowledge base will start searching from top to bottom and look for a predicate that starts with ingredient. Okay, I got it. I got the first ingredient. Does this fact have tangent in the first parameter? Yes, we do. That means the ingredient value must have aubergine in it, and the amount value should have 250 in it. So as you can see here, the amount value has 250 and the aubergine ingredient value has aubergine in it, because this is the first fact for which this parameter matches my query. But as mentioned before, Prolog knowledge base will search all facts. It won't stop here. It goes on to the next fact. Does the ingredient predicate match? Yes, it does. Does the first parameter tangent match? Agreed, it does. So that means since I have another match, the ingredient must be tomato and the quantity must be 100. So now we got a second instant, which we got a fact matching the tangent requirement, in which case ingredient is equal to tomato and amount is equal to 100 as mentioned here. So this again is a concept of instantiation. We'll be discussing that in a bit. Okay. Similarly, if we run it for stew, same process, my knowledge base will be searched for the fact ingredient, and when it does find ingredient fact, it searches for stew in the first parameter. No, failed. Okay, now this is true. If this is true, that means my ingredient must be beef and the quantity must be 400. Same thing goes with the next fact. The ingredient must be potato and the quantity must be 600, as you can see for this outcome here. Now, this is where the anonymous variable comes into play. And as you can see here in my query, as you can see here, these are my queries, by the way. This is what I have written to search for. And again, for running queries, as mentioned before, I have no knowledge of what the knowledge base is exactly. I mean, you can see this here just for understanding point of view, but most knowledge bases that are in currently being used around the world, the knowledge base is not visible to the end user. The end user simply uses his way of writing a query to assess whether something can happen or not, and they have no previous knowledge of whether what the value is going to be outcome. So that's the essence of your Prolog programming language. Now again, I am running a new query here, and this one I'm using an anonymous variable. Now what does anonymous variable mean? Anonymous variable means that if a particular fact requires more variables and I don't want to use all of them for my query, I can simply go ahead and mention this underscore over here. Now what that does is it simply omits this particular value from the end result. As you can see here, I have mentioned the anonymous variable underscore for the amount parameter, because of which my final results for ingredient with stew as the first parameter results the ingredient, it returns only the ingredients. So as you can see here, it returns beef and potato, and the ingredient, the amount part, since I left it out, I intentionally left it out. I don't want that result to be returned. It's not mentioned here, and hence the term anonymous variable. So if, for example, I ever want to leave out some facts, and I can basically formulate my query in such a way that if I want to leave out some data, I can by using this anonymous variable underscore.